Okay, here we are on page 5. Here, we're going back to arc length. The radius of a circle is 1, as denoted right there. Arc length, what we're going to know for arc length and what you should have on your cheat sheet is that the degree measure in radians is equal to arc length, which is S, divided by the radius. Theta equals S over R. And so what we are given here is we're given an angle, so that's our theta. Theta equals pi over 5. The radius of a circle is 1, so we're given 1. And we are looking for this arc length right here. That is RS. So that is unknown. So that means that pi over 5 is equal to S, which we don't know, over 1, which if the radius is 1, S is this, the arc length is the same as the radian measure of the angle, so it's pi over 5. Here the radius circle is 1, and so R equals 1. The arc, this says the arc is, so that's S, is 14 pi over 9. And you have two choices. You can either plug this into the formula where theta is, so we're looking for the angle, this angle right here. Since see that our arc length is right here, we start right here and go around when we measure arc length. So we start from here and we go in a counterclockwise direction. So we can do this, say theta is equal to our arc length, which is 14 pi over 9, divided by 1, which is r. So theta is equal to 14 pi over 9. If instead you just notice that the radius is 1, if the radius is 1, the arc length and the radian measure is exactly the same. Exactly the same. Right here, the radius of a circle is 11. So I don't give you a circle this time. Sketch your own. When you're in doubt, just start sketching. Sketch it and you can visualize stuff so much easier. So much easier. And it has a radius of 11. So R is equal to 11. What is the measure of the angle? So we don't know theta. So there is some angle right there. There is some angle. We don't know. It's theta. But we do know that this arc length right here is 19 pi over 2. I know this is not to scale. We don't care. It's abstract. This is good enough. This is good enough for a sketch because the equation will fix it all for us. Theta is equal to S over R. My theta is unknown. My S is 19 pi over 2. And my R is 11. So we have keep, change, flip. I keep the top part of the big fraction. So again, that line is bigger for a reason. So I keep the top part of the fraction. I flip the bottom part, so 11 becomes 1 over 11. And the theta measurement is going to be 19 pi over 22. So that is it's pretty close to 1 pi. So if I sketched it properly, it'd be like right out there somewhere, I bet. Okay, the terminal side of an angle in center position intersects the unit circle at 5/13 and 12/13. So again, this is unit circle, standard position. So that tells us that that guy right there is cosine, and this guy right here is sine. Always, always, always. So sine is 12 over 13, cosine is 5 over 13. Tangent is sine divided by cosine, so that's 12 over 5. Hopefully I'm not going too fast on the tangent part, but it's pretty much sine over cosine. And every time you do that, every time, the denominators cancel out. So you can just pick the numerators and put them over each other. Cotangent is this flipped, so it's 5 over 12. Secant is cosine that's been flipped, 13 over 5. And sine is, or sorry, cosecant is sine that's been flipped, so 13 over 12. Hey! And we burned through that page in, what, less than 6 minutes. Great. We got one more page, and I'll see you on page 6.